welcome to our session 8A, and we have here 1, 2, 3, 4, 5, 6 presentations, and hopefully everything is working perfect. Once again, my name is Wlodek Kulesza. I am professor at Blekinge Institute of Technology in Sweden. So I will not show you the window because the weather is very sad today, so you will not be depressed by my weather. I see that you have much more light in your windows and so on, so probably it is much better weather. Unfortunately, we are only on Zoom. We cannot meet personally, what is really a pity, because if you haven't been in Palanga, you should regret that you haven't been. It is so a lovely place. I've been several times at this conference, and I think that is really nice place. And please work on your research to submit paper next year. So hopefully we can meet in Palanga next year. So the list of presenters is already known for everyone. This is a session dedicated to automation and robotics. And I am chair, my chair, professor chair, is in multi-sensor system and in automation. So I should be competent in your presentation, I hope. Any question? No questions. So the first presentation will be done by Dawid Gradolewski, who is my PhD student. I must admit that we have some, let's say, we know each other at least. Okay, thank you. Dawid, the floor is yours. Maybe not floor, but the screen is yours, please.
Thank you very much. Can you see my presentation? Good afternoon. My name is Dawid Gradolewski, and I am a PhD student from Blekinge Institute of Technology, Karlskrona in Sweden. Today I would like to present the last result of our work aimed at the development of distributed computing real-time safety system of collaborative robot. The research work conducted under the supervision of Professor Kulesza. During the modeling and prototyping phase, also Dawid Maslowski, Damian, Dziak, Bartosz, Jachimczyk, SivaTeja, Mundlamuri, and Chandran, Prakash participated in the project. The model was developed in Intema and is currently under the evaluation. This research was funded by the National Center of Research and Development of Poland. And the outline of my presentation would be as follows. First, I would like to show the objectives of the research. Then I will jump to the design methodology and solution and prototyping. At the end, I will show shortly the validation and the results and follow the conclusions. Robotization is an efficient and cost-effective approach in modern factories. More and more robots and manipulators are placed in the workplace shared with the humans. Such close cooperation between humans and robots may lead to hazard situations, even to human death. The main objective of the thesis was to find a reliable, cost-effective and real-time solution of a safety system of the Cobot to detect, to identify, and even to localize humans approaching the operational zone of the robot. The system reliability in the changeable surrounding environment without compromising machine productivity is crucial for this research. In this research, we use the driven design methodology to define all functionalities and constraints of the system. The design process was systemized, and each stage, both the stakeholders and the future users were involved. The design product is mostly dedicated for a medium and small sized companies where price and easy to adjust the manipulators to other tasks is crucial. The defined general and itemized functionalities are summarized in this table. We selected 7 crucial functionalities, which are safety system, object detection, detection classification, object localization, threat classification, Cobots motion control, and interfacing. To all the functionalities, we itemize and give particular constraints of each of them. To each, we try to define all the possible technologies and algorithms which can fulfill the requirements. And during the analysis, we find the most suitable one. After the analysis, we came up with the solution, which are the IoT-based distributed computing safety system. The safety system is design of the IoT concept, where users has easy access to each subsystem through the GUI. All data is stored on the previous detection and regarding the system performance on the database. The safety system is composed on sensing detection modules, decision-making system, and the robot, which all of them are connected with the internet. The data processing is decentralized, so the computer overload is reasonable. The hardware configuration of the system is presented on the left-hand side. It consists of the camera, ultrasound sensor, and stepper motor for sensing rotation. The number and the configuration of sensing detection modules depends on the customer requirements and the Cobots vicinity. To cover all the surroundings, up to 6 modules are needed. The module configuration schema is presented on the right-hand side. We divide the Cobots operational area on the 3 zones. The green one is the safety zone. The yellow one is the warning zone, and the red is the dangerous. The black zone is the robot's working area where hazard situation may occur. On this slide, the flow chart of the system is presented. It consists of 2 parts, the sensing detection module and the decision-making system. The sensing detection module is the pre-processing part and will be described on the further slide. The decision-making system is working on the cropped images sent from each modules. First, the cropped images is identified and the valid and invalid detection counter is calculated. If the invalid detection counter exceeds in the certain time some threshold, we update the background frame. When the valid detection counter in certain time exceed the threshold value, we do the predefined Cobot motions on the system. The sensing detection module algorithm is based on the motion detection. First, the background and the current frames are converted into grayscale. Then, to minimize the false detection of small patterns of the image, the blurring is performed. On the later stage, the absolute difference between the corresponding pixels are calculated. Next, the differential image is calculated and thresholded to reduce some artifact caused by lights. Then the cropped image is sent to the identification process. This slide presents the system prototype with 2 modules. The decision-making system were implemented on the computer with the GPU. The system prototype consists of camera, ultrasound sensor, and the stepper motor. The stepper motor is used to direct the ultrasound sensor towards the detected objects. On this slide, we have the results of the image pre-processing part. The system have been tested in real environment. 3-person walks around the room with changing background. The cropped images were sent to the computer for further identification. We can see here also that some false detections which were further analyzed in the identification process. In the identification process, we tested 3 different algorithms, state-of-the-art, which are Hawk, Villa-Jones, and YOLO version 3. The measured false positive detection efficiency along with the maximum latency and frame per seconds. The measured latency was measured as delay between the appearance of the object in the zone and its identification by the decision-making system. The frame per second allows us to evaluate the system complexity. Overall, YOLO versus 3 outperforms other algorithms in terms of detection efficiency and in terms of false positive rate. To select a suitable camera resolution and impact on the image resolution and the system latency, and FPS was estimated. We performed a 5-minute test to do this. A person walks in a room and we calculate the identified objects. And for each, we calculate the frame per second and the latency. We can see that the resolution HD meet the user requirements of latency not bigger than 200 milliseconds and the frame per second with more than 10 frames. Another test was dedicated to estimate the accuracy of the localization measurement. It is important to know how well object is localized within a particular zone. One human at the time walked in the observation area and approached market points. These points were distributed within 3 different angles of 15, 30, and 45 degrees and placed at 4 distances from 100, 220, 350, and 470 meters. For different distances, we measured the uncertainty and the standard deviation of the error. It came up that the uncertainty varies from 3% up to 20%. And this meet the user requirements. This research shows the capacity of developing the most reliable real-time safety system of Cobot, which is able to detect and to localize human multi-objects approaching to the Cobot's operational zone, and then providing a decision about a suitable action of the Cobot's control. The systematic design approach of the user-driven design methodology facilitates a development of the system, which makes all requirements and constraints defined by future users and stakeholders. The modular construction embedded into distributed computing paradigm, basing on the self-components, ensures high detection efficiency and low costs of the system. Thank you for your attention.
Okay, thank you, David, for a nice presentation. And this is a little bit complicated now, maybe with the questions, but I think that all the presenters may have also a question. If you just have a question, just open your microphone and state your question. And the audience who are watching us at YouTube, please type your question. There is some window, is some bar, top chat, where you can type your questions. I see that we have some small delay between presentation, what I see on Zoom and on the YouTube, but I think that David also, I can read the question to him. So David, waiting for the others, I have to take my opportunity to ask you the question. And of course, you show the how to say lighter side of your project. So everything what was successful. What was drawback of your project? What is the drawback of your solution? If you may find it.
Maybe not the drawback, but maybe the future work. I think it would be nice to extend and to evaluate the system on the larger number of the detection models, because on this research, we tested the system on just 2 models. We still have some capacity on the server side, so to test how the system will act with the more modules connected to the server. So maybe it is the main issue of future work.
Okay. Do you have another field of implementation of similar system? If we did, because you said here it was dedicated because your stakeholder had, let's say, specific requirements, but do you see that similar system can be used, I don't know, at airports or somewhere else? So what is your idea?
Yes, because it's when we just change the identification algorithm to the different parts, we can detect each moving object. So it's just the measure of the identification algorithm.
Okay. And this system has been already implemented, and I guess it is in production, or how does it continue with the research?
It's already implemented in the company. This project was funded by the grant from the National Center of Research and Development, and currently this product is at the last stage of the development, so it's during the evaluation and during the tests in the company.
Okay, I don't see any question written in the chat and so on, so I don't see anyone who raise a hand to ask a question. So I think that I will make all the time the individual upload, because usually we do this upload. So thank you, David, and
thank you very much.
Please switch off your sharing, and we will invite now Mr. Xu Baoyan. You can introduce yourself and tell where you are from which city, and so it would be interesting to know. David, you haven't switched off your sharing, because until you will not switch off, we cannot continue. Still, David, we see your, now. Okay, Mr. Xu, are you ready?
Yes, thank you.
Please, the screen and the floor is yours, please.
Can you hear me?
Yes, I do. We do.
Okay.
Speak a little bit louder, maybe, but we hear you.
Okay. Good afternoon. I'm Baoyan Xu, a PhD student from China Agricultural University, and it's my honor to give a presentation here. The title of my presentation is Optimization of Threshing Quality Control Strategy based on Type 2 Fuzzy Logic Rulers. I'll conduct my presentation from the following 6 sections. As we know, threshing is one of the most crucial functions of combine harvester. Grain loss and crashing are essential parameters to evaluate the threshing quality, but it is still tricky to control them effectively. We can see from this picture, when the ruler rotates, the threshing teeth penetrate into grain crop mat in threshing cleaver. Grain areas are impacted by high-speed threshing teeth with additional action like compression, rubbing, and combing. Green kernels are detached from socket with a serration results from impact. Then green kernels fell into open between neighboring conical grids. Therefore, conical clearance and drum speeds are the important factors affecting the loss rate and the crashing rate. But it should point out that the existing literature on fuzzy control strategies do not take into account the uncertainty of environment. Consequently, it is not reasonable to use an accurate membership function for measurement data without considering the fluctuating and disturbances. These people proposed a new control strategy based on type 2 fuzzy logic controllers to improve threshing quality. The control strategy based on fuzzy idea must obtain the relationship between parameters. Therefore, in order to obtain the relationship between concave clearance, lunar speed, loss rate, and crashing rate, the basic data acquisition test is designed. The detection part of the threshing separation quality system installed on the combine harvester mainly consists of 6 parts. Crashing rate not, lunar speed not, green loss rate, green loss not, concave clearance not, data acquisition terminal, and computer. The field harvesting experiments was conducted at Beijing Xiaotangshan. According to national standard equipment for harvesting combined harvesters test procedure, the concave clearance was adjusted as 10 millimeters, 50 millimeters, and 20 millimeters, and the test results are shown in picture. And 2 rules can be obtained from the result. The first one, when the concave clearance is 10 millimeters, 50 millimeters, and 20 millimeters respectively, the grain crashing rate first increases and then decreases. Another one, when the concave clearance is 10 millimeters and 50 millimeters, the grain loss rate decreases with the increases of speed of the drum. But when the concave clearance is 20 millimeter, the grain loss rate decreases first and then increases. In order to improve threshing quality, 2 control strategy would be designed based on experimental data. One is low grain loss rate. The other one is low grain crashing rate. In low grain loss rate control strategy, input variables are loss rate and concave clearance. Output variables is drum speed. In low grain damage rate control strategy, input variables are grain crashing rate and concave clearance. After variables is drum speed. Before designing the control strategy, let me introduce the type 2 fuzzy logic controller briefly. In the clustering coordinate system, the type 2 fuzzy sets can be expressed as a two-dimension region, which is called the footprint of uncertainty. It's the unite of all primary memberships. The upper membership functions and the lower membership functions are the boundary of footprint of uncertainty, and can express as type 1 for these sets. Refer to this reference for detailed mathematical series of type 2 fuzzy logical controller. In low grain crashing control strategy, one input sets damage rate. Damage rate is defined by three membership functions: ND, MD, and LD. In the interval, another input sets coin clearance. Clearance is defined by three type 2 fuzzy Gaussian membership functions: SG, MG, LG. In the interval 10 to 20, the output sets linear velocity of the threshing roller consists of 5 membership functions, which were MI, SV, MV, LV, MA in the interval 800 to 1200. Characters of the inputs and output of grain damage type 2 fuzzy logic controllers are recorded in detail in table. According to experiment data, 9 rules of grain crashing fuzzy logic controllers are established. Similar to grain crashing with control strategy, in lost rate fuzzy logical controller, lost rate set is defined by 3 membership functions, which are SL, ML, and LL in the interval 0.25 to 0.6. Consequent clearance and roller space sets are equal to grain damage control strategy respectively. Similarly, 9 rules are designed according to the experiment data. In order to test the controller, grain damage and loss rate type 1 fuzzy logical controllers are designed and compared with type 2 fuzzy logical controllers with the use of fuzzy toolbox from MATLAB. Moreover, to evaluate the response of strategy, integral of square error and integral of absolute error are used in this section. Type 1 fuzzy logic controllers and type 2 fuzzy logic controllers of grain damage are built in the fuzzy interface edits in MATLAB. When the value of coin clearance are 10 millimeters, 50 millimeters, and 20 millimeters respectively, there are always an error between the outputs and the output of fuzzy logic controllers and the fitting curve amount on account of open loop system. However, their trends are consistent, as can be seen. Integral of square error and integral of absolute error of type 2 fuzzy logic controller are less than type 1's. Those values indicate type 2 fuzzy logic controllers performance better than type 1. In order to verify the effectiveness of the control strategy, control and uncontrolled experiments are designed. In field experiments, the loading speed of the roller calculated based on the control, and the roller speed is set as the calculated value. From the experiment result, they can be seen that the crash rate and the loss rate of the control experiment reduced to a certain extent when the concave clearance is 10 millimeters and the speed of the roller is 900 RPM, as the loss rate and the crash rate decrease the most, and the amplitude are 44.6% and 25.26% respectively. When the coin cube clearance is 15 millimeters and the loss width is 900, the reduction of loss width is largest. And the reducing of crashing rate is the largest as 25.84%. When a coin cube clearance is set as 20 millimeters and rotation and the speed of rollers is 100. The reducing of loss rate is the largest, and the speed and the rotation speed of the rollers is 1100. The reducing of correction rate is largest. In summary, crash rate and loss rate are reduced significantly. So the threshing quality control strategy is effective. Conclusion. To design the model of type 2 fuzzy control, combine harvester threshing quality automatic monitoring system is designed in people. On this basic, the membership function of the variables and fuzzy controllers of control strategy are proposed. For varies the response of type 2 fuzzy logic controllers, type 1 fuzzy logic controllers is designed as the objects of comparate simulation experiment. The field experiment results showing that the type 2 fuzzy logic controllers give the coin cube clearance and the loss rates can significantly reduce loss rate, crash rate, and improve threshing quality. Thank you for your attention.
Okay, thank you, Mr. Xu, for your nice presentation. And we are still open for questions in YouTube. If anyone has any question, please type it. And also, as I said, anyone who is attending Zoom can ask a question. May I start with one question? What was the reason why you started to work with this fuzzy controller? Because there are probably hundreds of possibilities. So what was the motivation of choosing this kind of controller?
Because fuzzy logic controllers is
do you see we have some problem with that you cover your picture with some gray box? I don't know what is this, you see?
Okay.
We had this problem all the time. So you see still there are some gray squares on the top and on the right hand side.
Square.
You know that the gray boxes that you have on the top on the right of your screen. I don't know where it is from, but it is some problem. Maybe fuzzy logic is needed to rid of this. Do you see this on your screen?
My English expression is not very good.
没关系, 没关系. Continue. Okay, yes. So what is your motivation, please?
Because agricultural control is not precision controlled. So I chose the fuzzy logic control.
Okay. when you can come to your conclusions, please, on the last, next to the last slide. When you, at this last conclusion, you said that you gain damage rates and maximum decrease in losses. What do you compare it with? Do you compare it with this type 1, or what is the reference to this gain that you got? To regular controller, or to which kind of controller you apply this reduction and decrease and so on? So because we need to know what is a reference point of your result.
Because my English is poor.
No, mine is not the best neither. So you know, but we can communicate anyway.
What do you say? Maybe we could exchange our opinion by emails.
Okay. So I will send you some question by email, and you can explain. So we can leave it maybe somewhere on the website of the conference. Okay. Thank you, Mr. Shu. As I said, you have individual just upload. So thank you. Please switch off your sharing. And now we are going to listen the presenters from Pakistan, Ms. Rabia Tehseen. Please switch on your microphone and your video and share with the screen with us. The floor and screen is yours, please.
Should I start?
Yes, please.
Assalamu alaikum. I am Rabia Tehseen from University of Management and Technology, Lahore, and I am here to present my paper, Fuzzy Expert System for Earthquake Prediction in Western Himalayan Range. As we all know, earthquake prediction is a complicated task, and people have been researching on this phenomena to extract certain parameters that might be helpful for determining or predicting future earthquakes. We are also working in the same line to explore the need for the application of computational techniques provided by artificial intelligence for extraction of structured parameters from unstructured, noisy, and bulk data. We have been motivated for the application of fuzzy logic for the generation of fuzzy expert system, because fuzzy expert system allow us for the application of linguistic variables with fuzzy rules that are human understandable. These rules increase the transparency and interoperability with the data set. And furthermore, due to transparency, modifiability, comprehensibility, and coherence with previous knowledge, fuzzy expert system can be tuned, updated, and adapted if necessary, thus enhancing the degree of freedom in problem solving. Moreover, as compared to other approaches like neural networks, which are just providing an opportunity for training data that are wholly solely based on training data set, and they are working like black boxes. Fuzzy expert system is providing interaction with the human experts that have solid knowledge of the domain and facilitators for making earthquake predictions. Then the domain of work, actually we have worked in cross-domain. Mainly our work is on fuzzy expert system, that is a branch of artificial intelligence. We have combined it with seismology. We have taken the data set from seismology and joined it with artificial intelligence and developed a fuzzy expert system for earthquake prediction. The data set we have used instrumentally recorded seismic data set obtained from USGS from last 20 years data within 100 kilometer radial area from 34.708 degree north to 72.5478 degree east. And we tried to predict the earthquakes through our fuzzy expert system with magnitude 5.5 or greater in the specified region. We have studied multiple articles before writing this paper, and some of the articles have been presented in this table. It is clear that reactor number 3, 5, and 22 have worked in Pakistani zone. Number 3 have applied image recognition techniques. They have taken images from seismographs and analyzed these images. Whereas 5 and 22 have applied back propagation and forward chaining neural networks. But our work is different from both of them because we have involved human experts. We have taken their judgment while setting our rules and developing the membership functions for the earthquake prediction. This is main methodology of our paper. We have divided the seismic data set into 2 groups. This is the first group that is presented by X. It consists of all the direct parameters, the parameters that have been directly extracted from seismic data. And then the set Y presents the derived parameters, parameters that we have applied, calculated after application of certain formulas on direct parameters. Then these 2 sets are interlinked with each other. They do overlap with each other because some of the parameters, because it is very difficult to define which parameter will belong with which set. So the founder of fuzzy logic, ZD, has helped us in this regard. If the membership value 1, membership function gets the parameter, gets the weight factor 1, then it will be belonging to the same set. And if its value is 0, then it do not belong to the set. And if the value is intermediate, then it may belong to the same set. On the basis of this rule, we have divided our data into 2 sets, X and Y, and then we sent these 2 parameters as input value to our NFIS, Adaptive Neuro-Fuzzy Inference System. In the layer 1, that is fuzzification layer, all the variables that are coming from outside, the crisp variables, has been converted into fuzzy variables on the layer 1 so that they may process according to our rules. Then they go to the layer 2 where fuzzification and is done. Actually here rules are being applied. The rules that have been set by the expert's opinion, they are applied on fuzzy and layer. And then the normalization layer. In the normalization layer, we have applied the function that we have developed on the basis of layer 2 results. After applying these functions, we multiplied it with the weight assigned to every result. The weight factor has been calculated using the product function of all the linguistic tags with the results that has been generated by layer 3. After that, defuzzification has been done for the extraction of predictions about earthquakes, about the future earthquakes. The defuzzification function has been applied using centroid method. Through centroid method, it usually determines the values that will be most prominent while determining the earthquakes. This is the data analysis screen, which shows we have extracted the data from last 20 years and this is seismic energy, cumulative seismic energy that is being accumulated underground. This is the analysis of seismic data, and we have determined that in year 2004 to 2005, the energy is getting accumulated underground, and it is not being released over the ground. That's why this circle is representing seismic quiescence period. Again, from 2014 to 2015, we again had seismic quiescence period. It means seismic energy is gathering underground and it is not coming out. So in 2005, we had a catastrophic earthquake in Pakistan. And again in 2015, we again had a major earthquake of magnitude 7.5 in Pakistan. The figure B presents 5-year microseismicity pattern. From the same data, we have extracted 5-year pattern to show that microseismic events stopped occurring immediately before the occurrence of 2005 event. You can see here the rapid slope that is coming down towards 0, which shows that the occurrence of micro earthquakes that usually occur before a major earthquake has almost narrowed down. And then suddenly earthquake of 7.8 in year 2005 has encountered in Hazara region. We have simulated our fuzzy expert system using MATLAB. Here from these images is a figure A presents that energy gathering underground and the energy release is very low since the long time has passed, so expected magnitude would be higher. More magnitude could be expected here. More magnitude is expected here. And figure B presents that if the earthquake has low depth, if depth is near zero, then it will cause more rupture due to major with the major magnitude. The magnitude that will affect the earth will be high. And then the figure C presents if depth is narrow, if long time has escaped and no earthquake has occurred, then earthquake with narrow depth, that is like 10 meters below the earth or 15 kilometers below the earth, and then expected magnitude would be higher. We have implemented simulated it in MATLAB. These are the results of our method. We have trained our model using seismic data that are of true seismic data and the training data. We have added them in the true responses and predicted results. Both are added in model 1.1. And in second figure, it is presented that we have found matching values, like the actual earthquake that have occurred and the earthquake that we have predicted. And it is being shown that 47% of our predicted earthquakes on the historical data have been correctly predicted. So our model is capable of predicting about 47% of earthquakes accurately from historic data. Conclusion. In this research, we have presented fuzzy expert system for earthquake prediction. We have extracted multiple parameters from the data set that have been passed to fuzzy expert system as input. Multiple rules and membership functions described by human expert have been applied. We validated the data using MATLAB. We have generated the model. The model has given us 47% of accuracy. And in future, we intend to apply machine learning on the same data set for improvement of our accuracy so that we may gain 60% or 70% of accuracy. Thank you.
Okay. Thank you very much, Ms. Rabia, for your nice presentation. And this is a very interesting topic, at least application field, of course. And so waiting for some questions maybe from audience and others. Let me ask maybe some simple questions, because when you said that your reliability of your system is 47%, this is what you said. Did you compare it with the other systems? Because I guess, you know, this is probably very hot topic everywhere. And so what is the best of the best now on the market in this area? What is the reliability of the best?
Yes, sir, very good question. Actually, sir, when we use training data, when we overfit our training model, then we can get 100% accuracy. We can get it, but it is because of overfitting. If we control overfitting and make real predictions, then prediction rate got down to 67% or 68, maximum 68% have been predicted using neural network models. But neural network do not involve humans. They simply take data set, they pass it from the model, and the predictions are made. They do not give importance to human knowledge, whereas expert system is a field that has severe impact because everything is going on underground, and we have to focus on all the parameters that we cannot see, like weather forecast. Everything we can see, but we cannot see under the ground. That's why we are getting low accuracy. But getting 68% accuracy using neural network and machine learning model is a good one. We need to improve accuracy because our accuracy is 47%, but we have taken data from only one aspect, that is seismic aspect. But if we get data of the same region from multiple aspects, then accuracy will be improved. Like if we get reservoir data, we get climate data, we get temperature data, ionosphere data, then the accuracy will be improved definitely.
Okay. I hear that someone put the question on the YouTube, maybe. Where is this? Do you see any question? No, I see just for okay. Do you see YouTube as well? Because I cannot recognize any question here. Darius has informed me that there is some question, but I don't see exactly which one is this. Okay, maybe I will recognize it later. But the next question would be, because you showed that you divided this data set into sets, X and Y. And you said that the Y was created by some equations from the measures that you get. I don't get how did you created this Y set? So you know which equations to use, because you said that you use some mathematical, let's say, relationship between this measure and you created this input Y to fascination.
Very good question, sir. Sir, actually, we have divided our data set into two groups. One is X and other is Y set. We have divided it into direct parameters and derived parameters. When we get data from regarding seismicity, seismic data, when we get magnitude, longitude value, latitude value, its depth, the area that has been affected from it. These parameters are called, these are the direct parameters that have been obtained from data. And then we have applied formulas. We have defined formulas for the calculation of rupture length, for the calculation of B value maybe. We applied these formulas that are defined by seismology for the determination of derived parameters that are passed to fuzzy expert system as Y. And after that, giving this input, we applied mathematical formulas to generate fuzzy functions. Fuzzy rules has been explained by human expert, and on mathematics, we have applied mathematics for generation of membership functions. Okay. Set X and set Y has been discriminated using seismic data. Seismic set X, the set X has already been obtained from the direct parameters that are directly described in seismic data set.
Okay, I see some comments from the YouTube. First of all, someone is proud of you. Rahan Hasim said or wrote that is proud of you, if you don't see. But I see the question from Prakash Chandran. The question is to Rabia. What technique is used to validate your MR fuzzy model, and what is the accuracy?
Our accuracy is 47%, and we have used 5-fold validation technique while developing our model, like I have seen in this stage. Prediction model 1 has been developed using cross-fault validation technique, in which we have calculated the mean square error and absolute error, and our error rate was 0.21 at that time when we trained the data, and obtained accuracy of 47%.
We have another question even, a part of the upload, that nice presentation. And the question is, did you consider or will you consider evaluating with time series forecasting models like LSTM or RNN?
Actually, not in this paper, but the next article that we are writing right now, we have applied time series in that model. In that article, we have extracted data from multiple sources, and we are applying time series on that so that we can make real-time predictions. We are working on that, but in this paper, we have not worked on real-time data.
Okay. So thank you. It was nice that we got the questions from the audience on. It means that your presentation really created some interest in our audience. So thank you very much, and individual applaud for you. Thank you very much. And
Thank you,
now we are moving to the next presentation. And the next presentation is going to be done by Mr. Mehmet Latif Levent. Could you please switch on your
I
camera?
am here.
Okay, nice, nice. Nice to hear you that's still waiting patiently for us. So please start your presentation with sharing your screen. And the floor is yours, please.
Hi, thank you for your kind introduction. I am here today to introduce our new research. Let me introduce myself and my team. I am working as a research assistant at the Hakkari University in Turkey, and Ömer Aydoğdu, my mentor, works as a professor doctor at Konya Technical University. My talk is particularly relevant to the adaptation mechanism as a new approach. The title is State Estimation with Reduced Order Observer and Adaptive Linear Quadratic Regulator Control of Time Varying Linear System. I have divided my presentation into 7 parts. In the first part, I give an overview in introduction. And this next section, I will explain modeling of variable loaded servo system as planned as system. In part 3, I am going to show state estimation, and then I will explain proposed method. In the last part, I would like to give simulation results and conclusion. First of all, I talk about an overview in introduction. In this study, a new controller design was created to increase to control performance of a variable loaded time varying linear system. For this purpose, a state estimation with reduced order observer and adaptive linear quadratic regulator control structure was offered. Initially, to estimate states of the system, reduced order observer was designed and used with linear quadratic regulator control method. That is one of the optimal control techniques in the servo system with initial load. Subsequently, a Lipno-based adaptation mechanism was added to linear quadratic regulator control to provide optimal control for varying loads as a new approach in design. Thus, it was aimed to eliminate the variable load effects and to increase the stability of the system. In order to demonstrate the effectiveness of proposed method, a variable loaded rotary servo system was modeled as a time-varying linear system and used in simulation in MATLAB Simulink environment. Based on the simulation results and performance measurements, it was observed that the proposed method increases the system performance and stability by minimizing variable load effect. In this second section, I explain modeling of the variable loaded servo system as planned as our system. As seen in this figure, a rotary servo system that can alter the load in time was used in the experiments. In industrial applications, permanent magnet DC motors are widely used as an actuator for electromechanical energy conversion. It directly provides rotary motion or moment and can provide transitional motion or force when coupled with wheels or drums and cables. The variable loaded servo system actuated with a permanent magnet motor, which has the electric circuit of the armature and the variable loaded body diagram of rotor are shown in this figure. Permanent magnet motors, which are frequently preferred since they are easily controlled, have been widely used in recent years. These motors have important features such as having no use for excitation current, quite low energy consumption owing to the field fluxes they produce, and low cost owing to their small size compared to the other motors. In industrial applications, the high performance and stable functioning of the system are two very important criteria. In order to meet these criteria, many different approaches have been used in the literature, such as proportional integral derivative control method, sliding mode control, field programmable gate array control, adaptive control, fuzzy logic controller method, and reduced order nonlinear observer. Now I am going to show state estimation. Accurately estimating all the unmeasurable states of the system is an important factor that influences the functioning of the plant in high performance and stability. There are two important methods in state estimation called as observer and Kalman filter. In this study, we used reduced order observer. The full order observer method is applied to estimate all the states in the controller designs, and the reduced order observer method is applied to estimate unmeasurable states. This control structure is used in particular induction motor control, sensorless electric drives, permanent magnet, synchronous motors, linear time delay systems, aircraft motion control, and multi-agent system. Reduced order observer structures are commonly used for system design that provide ease of operation by reducing degree of observer. We can show state estimation with reduced order observer block diagram. The reduced order observer equation is given, and the block diagram that is fit for this equation is represented in this figure. Yes, state estimation. Now I will explain proposed methods. The proposed control structure in this study is given figure in this figure. And actually, the optimal feedback gain matrix value for linear quadratic regulator were obtained from the Riccati equation for initial load. We can see liquor block Riccati solution for initial load, and then therefore, optimal control is not provided with these gain parameters when the load change. When Lipman stability creditation-based adaptation mechanism, as shown, is added to the system, the state feedback gain matrix value will change adaptively, adapt to environmental condition in variable load situation. A Lipman-based adaptive mechanism was added to linear quadratic regulator control to provide optimal control for varying load as a new approach in design. We can see Lipman-based adaptive mechanism as a new approach. This figure shows the block diagram of the Lipman-based adaptation mechanism as seen previous section. Lipman-based adaptive mechanism, and the reference signal states that are estimated by reduced order observer x1, x2, x3 reference signal, and linear quadratic regulator output. We can see A1, A2, A3. These parameters are defined as inputs in this related block. In this system, different adaptation blocks for the state that are position, speed, and current x1, x2, x3 are designed. The first block provides position control. We can see first adaptive lifelong stability criterion 1 is position control. Second block provides speed control, and the third block provides adaptation for the current control. In this regard, the purpose of the research is to perform a new adaptive algorithm that ensures optimal state feedback of the system on variable loads. In the last part, I would like to give simulation results and conclusion. When adaptive linear quadratic regulator and reduced order observer with linear quadratic regulator control methods are applied in the system, the results for unvarying system are shown in this figure. We can see red line reference signal, black line reduced order observer with linear quadratic regulator, and a blue one adaptive linear quadratic regulator. Examining the error change shown in this figure, it is concluded that position output signal rapidly catches the reference signal, as is shown in table 2. Comparing the results based on their performance measurements, it is understood that the proposed system produced better results and has a high performance. The response of adaptive linear quadratic regulator and other control methods are given in this figure, and effects of the variable load that occurred after 21 seconds on the response curve of the system is shown in second figure clearly. We can see proposed methods catch the reference rapidly. Also, change of the feedback gain matrix value is given in this figure. Here it is observed that the gain matrix value changes in accordance with the environmental condition and rapidly minimizes the load effect, and we can zoom error after the 21 seconds and gain matrix value change in accordance with the environmental condition and rapidly minimize the load effect. Conclusion: the designed new control system with a linear quadratic regulator and reduced order observer is based on adaptive state feedback control that compensates the disruptive effects such as variable load and increases the system performance. This controller structure was successfully used in trajectory control of a servo system that can change the load over time in simulation. As is known, it is not possible to completely remove the disruptive effects. The system can estimate the states of the variable loaded servo system, thus the disruptive effects can be minimized. A stable system design that can comply with the environmental condition was prepared. It is observed on the simulations result that the proposed control method gives quite good results in controlling the system that are exposed to adverse effects like the variable load. The error between system output response and reference input signal was minimized in time. It is understood from the system results that the system control parameters can adapt itself in time. Thank you.
Okay, thank you very much for your nice presentation. And as usually, one of my duties is to make you busy with the question. And we are waiting still for questions on YouTube. Please, anyone who is watching us, please type your question if you have any, because it will be nice for me and for presenters to see such questions. My question would be more about applicability of your very nice research, because automation is the applicable science. So do you see any case study? Because I think that the next step of your research should be to verify your system on some process, on some devices and so on. So do you have any experience which system or which company would buy it and implement it on their systems, please?
Yes. It is, for example, control of permanent magnets, synchronous motor, and motor speed control. But in future, especially in more robotic application, for example, arm of robot or trajectory of control, and in a space application, it will be applicable personally.
Mm-hmm. Do you have any cooperation with a company that would be interested in this one? Because I think that, as engineers, we enjoy really that work, that's our work is implemented and it shows some.
There are a lot of implementation when I study in this work. For example, in fuzzy system, DC motor application, I study in DC motor and I research DC motor in literature. A lot of application was shown, and robotic application, space application, and there are a lot of, but especially I research this part of study.
I think that I see one question from Sai MJ, and I guess that is to you. First of all, he said that it was interesting and asked any future scope idea about this development of the system, I guess, yeah?
Feature.
Yes, some new future scope ideas, what it could be, because you know what you've done, but you should know what would be later.
In the there are a lot of works about this study, but personally in the future, especially in the space application, for example, trajectory or control in space, it will be applied, and especially in the future for more stable and more good performance in robotic application. It will be applied because this state estimation with reduced order observer and adaptive linear quadratic regulator control especially is applicable on variant linear system. So it will be applicable in the future personally.
Okay, thank you very much. And I think that even big guys like to appreciation or applaud. So thank you for your presentation. And now we move to the next presentation, which will be probably done from Beijing. And this presentation will be done by Mr. Wang Yuxiang. Are you still patiently waiting for your turn, Mr. Wang?
Yeah.
Okay, very nice. Yes, I hear and even I see you and smiling. So it looks that you are happy to be with us. So the floor is yours, please.
Okay. Could you see my PowerPoint? Okay. Okay, good
But
afternoon,
we
everyone.
still see some black. Please close all your applications, because someone wrote that what we see it is that you open too many applications. You have to switch off all applications to read of these black boxes, please.
Okay.
So just leave this one application that you use, and all others should be just switch off, please. Or many applications. We still see at least 3 or 4 applications open on your screen.
But yeah. In my screen, there is only the PowerPoint.
No, but we see, so you have to close the applications, please. We see it. Okay. I don't know how, but you can see it on your YouTube. If you see YouTube, you can see that what is the problem.
Okay, wait for a moment. This time, could you see my PowerPoint without the applications?
Now I see without applications, but we can see if there is also change in YouTube, because it's better to make this improvement now. Still, I see the applications. So close all applications. It will probably.
Yeah. I have closed my all of my applications except the PowerPoint.
But I see still them on the Zoom. Do you see on Zoom? This, you must see the same as what we do.
Okay, I will close this.
So you probably must have more applications. Yeah, close all of them.
Okay, I am doing. Yes. Closing.
Even if you write some comments to your sweetheart, she can wait for it.
Okay, this time I have closed.
Now it's probably working. Yes, just go ahead. Okay, good luck.
Just a PowerPoint.
Still one box is open. One application is.
Oh my gosh.
Now 2.
Now 2. Let me look. This time.
Yes, and one in the right upper corner.
Oh, I don't know what's wrong. So I will. I will restart this sharing.
Okay, restart it. Okay, we are waiting.
Okay. Okay, this time there is something wrong.
No, we still waiting. Still there is one black box.
Oh one. My God. Let me close. How about now?
Still, I see one. But maybe when you open the full screen, maybe it will disappear. Just open the full screen presentation.
Okay, I have opened the full screen presentation.
Not yet. No.
Not yet?
Still we have, but a small problem. Okay.
Okay, I will start my presentation. Good afternoon, everyone. My name is Yuxiang Wang, coming from Beijing Key Laboratory of Optimized Design for Modern Agricultural Equipment, colleague of engineering in China Agricultural University. Today, the topic of my presentation is a mathematical model and analysis of the crossing rate of compact harvesters. And my introduction will cover the following 6 aspects. First of all, let's look at background. Our research is based on field experiments, and the experimental location is in Weifang, Xindong Province, China. Xindong Province is the main area of wheat cultivation in China. During the harvesting season, compact harvesters such as GM18 produced by the Lovo company are the main harvesting machines. Lovo is one of the major compact harvesters manufacturers in China. Our research aimed at GM18, a semi-automatic longitudinal axial flow threshing compact harvester. As all we know, the crossing rate is an important index that farmers focus on and is the core competency of compact harvest. And the combine harvester is a complicated system. Crushing rate could be affected by multiple factors, such as crop status, operation parameters, working conditions, and so on. Also, crushing rate is a key parameter to evaluate harvesting quality. In order to ensure the harvesting quality and efficiency, the operator will frequently adjust speed, stubble height, and some other operating parameters of harvest manning based on their experience. It requires a vast experience of field harvesting and takes high labor intensity. Meanwhile, it's difficult for combine harvesters to keep the best working performance all the time. Therefore, identifying the effective intensity of each factor and obtaining the best combination will have great meaning for actual production. For example, our research could provide a reference for guiding field operation, which aims at improving combine harvesters' performance while reducing labor intensity. Also, the result of our research may guide designers modify their next generation combine harvesters. Our objectives of this paper is aimed at identifying the complex factors affecting crushing rate. Also, a mathematical model of the crushing rate was established through 4-factor and 3-level field experiments in this paper. The optimal operation parameters of combine harvesters were identified through range and variance analysis. Next, I will analyze various factors affecting the crushing rate in detail. First, let's look at the feed rate. The feed rate reflects the performance of the harvest. In general, a larger feed rate means stronger handling capacity and higher working efficiency. And multiple factors such as the density of grain and the cutting range and so on will affect feed rates. And in our experiment, we made some assumptions in order to control some variables. We saw that the density of grain will have small changes in the same group of experiments because the groups grow uniformly. And in our experiment, the cutting range didn't change because we always did full harvest. At the same time, during harvesting, cutter height maintained at a defined height. So the stubble height was almost the same. The only adjustable variable is operation speed, which can be easily controlled by drivers. In our experiment, we set 3 levels for feed rate, 4, 6, 8 kilometers per hour. Secondly, we controlled the rotating speed of threading cylinder. According to previous research by Lin Henliao, the high rotating speed with threading cylinder would cause strong heating force to the grain. Therefore, the grain is easy to be broken, which will cause high crushing rate. However, if the rotating speed is set to no, the increment loss rate will increase. As a result, we also set 3 levels for rotating speed of threading cylinder, 900, 1000, and 1100 revolutions per minute. The third affecting factor is the moisture content of grain. If the moisture content of grain is high, then no hardness and poor performance of resisting impact will lead to high crushing rate. But if the grain is too dry, poor toughness of the grain, no strength and poor impact will bring more broken grain. In this paper, experiments were carried out in the morning, noon, and earlier evening. The 3 levels of grain moisture content were 15.1%, 13.26%, and 14.4%. The last affecting factor we studied is concave clearance. According to relevant research, when the gap between concave plants increase, it will be beneficial to flow of crops and penetration of grains through the crop layer. Thus, crushing rate and entrainment loss will decrease. According to operators' experience, 3 levels of concave plant gaps are selected to match the threading cylinder speed, 10, 15, and 20 millimeters. The third part I want to talk about is experiment. Firstly, we designed a data collection system. Figure 1 and Figure 2 show the structure and the schematic diagram of this data collection system. The system is mainly composed of sensors, data collection system, data storage model, and analysis unit. On the combined harvesters, Hall sensors and the torque speed sensors are installed to measure the rotating speed of threshing cylinder. The GPS model can obtain the forward speed of the harvester in real time. CAN controller was used to collect sensor signals and to transfer analog signals into CAN message. Those messages will be immediately transmitted to computer for data storage and analysis. And for moisture of grain measurement, we used a grain moisture tester to do this job. Figure 2 mainly shows 3 parts of our system and the process of signal conversion. Before the field experiments, crop density needed to be sampled. And according to the China's national standard for measure methods, 5 points were chosen for sampling. And this process was displayed in those pictures like this. As a result, in this experiment, average crop density of the 5 sampling points was 1.7 kilometers per square meter. Also, the moisture of collected grain was measured and recorded by a grain moisture tester. In each experiment, the combined harvesters worked along a straight line, which was 17 meters. And the data generated at the beginning 20 meters would not be used because the state of combined harvester didn't get stable. Only when running at a constant speed, the data collection system would like to record the related parameters. The distance of data collection was 50 meters. Figure 4 shows the process. After each experiment, we would climb to the granary to collect grains in order to calculate the crushing rate. There is a video shows the full process of our experiment. The last part of our experiment is to calculate the crushing rate. According to China's national standard rules for agricultural seed testing sampling, the crushing rate was calculated by quadruple method. Firstly, we would spread the collected weight evenly on the board. Secondly, divide this weight into 4 parts. Then samples in 2 opposite triangles were further divided by the above method until the weight of the sample was close to 1,000 grams. At last, the crushed grains were screened out by experienced researchers as shown in this figure and weighted by an electronic scale. Then I would like to introduce the range and the variance analysis. Table 2 shows the orthogonal table with 4 factors and 3 levels designed for this experiment. For each experiment, in order to eliminate the influence of test errors on data, we repeat 3 times and then calculate the average value as the final result. Totally, we did 27 experiments, and 9 groups of test data were obtained. The experimental results are shown in Table 3. We use A to represent moisture content of grain, B for rotating speed of threshing cylinder, C for operation speed, and D for concave clearance. In order to determine the influence degree of each factor on the crushing rate, we did range analysis. As Table 4 shows, the value of R was calculated. The larger value is, the greater influence of this factor on the crushing rate is. So we could see the moisture content of grain and the rotating speed of threshing cylinder have almost the same significant impact on the crushing rate. Then followed by operation speed, which reflects speed rate. And the concave clearance have less impact on the crushing rate. At the same time, variance analysis also confirms this result. According to the result of range analysis, we could determine the optimal scheme. For factor A, we choose level 3, which the value of Ki is the smallest. So the optimal scheme determined with the same method is A3, B1, C2, D2. In other words, the moisture content of green is 14.4%, and the rotating speed of threshing cylinder is 900 revolutions per minute. Operation speed is 6 kilometers per hour, and the concave clearance is 15 millimeters. The performance of compact harvesters will be better when GM18 runs in this condition. In order to qualitatively analyze the relationship between those parameters and the crossing rate, the multiple regression method is used to establish the crossing rate model. Since the green moisture content has a great influence on the crossing rate, so the crossing rate and the threshing cylinder rotating speed are fitted separately under the same moisture content. After removing the abnormal data, the fitting results are as shown in this figure. Table 6 shows the regression equation of threshing cylinder rotating speed and the crossing rate. The last part is the conclusion and the expectation. Through this experiment, we can determine the optimal control parameters for GM18 compact harvester, and we think that orthogonal experiments with more levels could be designed to explore more exact mathematical models. Meanwhile, every year we will continuously collect data to establish a prediction model to estimate yield. Also, through our research, we believe that we will promote the development of compact harvester in China. Yeah, that's all my presentation. Thank you for listening.
Okay, thank you, Mr. Wang, for your presentation. Unfortunately, we are very short in time because I'm afraid that organizer will punish me if I will not finish in time. So I would appreciate if anyone has any question, please type it in the YouTube, and Mr. Wang will answer your inquiries. I see just that Dong Xiaowei, he or she very impressive by your presentation, so you can read it in the YouTube. So sorry, no question because we are a little bit over time. But if anyone would have a question, we'll send it by typing in YouTube. Thank you, Mr. Wang. Thank you.
Okay, thank you.
Thank you. Take care. So
okay.
I see that thank you. I see that we have a missing ship. So because Mr. Muazzamir Ali has shown up apparently, and he catch the train of the presentation. Mr. Muazzamir, are you present? Please switch on your camera and show up, please. Are you ready for your presentation?
Yeah, decision to open my video. I can't open my video.
You have to share the screen with us, please.
Okay, no problem.
Because we don't see your camera, we don't see your face.
No problem.
Maybe I open.
Can you hear me now?
Yeah, I hear you, but I don't see your face. So please open your camera as well.
I'm trying to open my camera, but I have permission.
No, you may have it. Allow.
You cannot
to stop
the video because
Okay. Oh, now okay. We see you. We have seen you before because you appear for a while on the screen and so on. So you know, we are a little bit short in time. So I hope that you will manage it in required time. Okay. Good luck.
I hope that.
Thank you.
Okay. Thank you, Mr. Hello, everybody. My name is Muzammil Tijani Muhammad Ali. I'm a PhD student at Konya Technical University in Turkey. Today I introduce my paper that titled as Pathologic.
Oh my gosh.
Excuse me? Can you hear me? Can you hear me?
We do. It was someone else, you know, just continue, please.
Okay. I will first introduce the traffic control system and its importance, and then I will move to the proposed methods that included how we can calculate the cycle time split, providing coordination between intersection, adjusting the green time, and then we discuss the simulation and scenario step, and conclude my discussion by the obtained result and conclusion. The traffic control is considered one of the typical complex system due to its non-linearity, stochastic, time variant, and so on. It's a method to managing a conflicting mixed movement vehicle, motorcycle, that using shared infrastructure. There is a lot of work done in literature, but most of them now use a non-cyclic strategy. That means there is no green time allocated to every phase within each cycle. This can be lead to unpredictable long time, at least at the side road. To overcome this drawback, we propose a cyclic method that assigns a green signal for all phases during each cycle. To do this, we use the Webster to calculate the optimal cycle, and then use fuzzy logic to control or to monitor the traffic situation. For calculation of the cycle, we use the modified Webster version that depends on the critical lane flow, which is represented by Y here. And then we split the calculated cycle time to each phase by using this equation: the optimal cycle minus lost time minus the dedicated minimum green time of each phase, multiplied by the number of the phase. Here we calculate the portion of the green time, and then calculate at the last the total green time that apply for each phase. How we can provide coordination between intersection? We are proposing two modes of the phase. We can select one mode at each time or at each cycle, mode 1 or mode 2. Mode 1 consists of phase 1, phase 2, phase 3, and phase 4. Mode 2 consists of phase 2, 3, and 4 is the same, and for phase 5 and 6 for arterial. For arterial, we use this combination of phase. The problem is dedicated as a combination problem. For this reason, we use two modes, and combination of these two modes is 46 combination. There is a restriction. For example, there is no problem if we use phase 1, phase 2, followed by phase 3, phase 4, or followed by phase 4 and for phase 3, because phase 3 and 4 is not coordinated phase for our proposed arterial. Here we, at the beginning of each cycle, we can calculate the distance or the time difference between each combination of the phases. This time difference can be calculated by using P and V. P is the phase difference, the remaining time of the phase, and D is the remaining time of the ice phase to be green, and the V is the remaining time of the head vehicle departed from neighbor intersection to reach the stop line of the ice phase. Our proposed system is work as in the flow chart. First, we are set the green time for all phases. Start by phase 1 for the first, and then we read from the detector the situation of the traffic for the reduce the computational power. We start to observe the phase after this time, and this adjusts the phase using fuzzy logic. If the time is less than 15 minutes, can we use the fuzzy logic to observe the phase, or is the max than or further than 15? We come here to check the green time of current phase. If it's 0, this means the phase is finished or not. This phase is not finished, we continue. If phase is finished, we check the cycle time is finished. There is a new cycle that we can use modified Webster to calculate, and then calculate the split and reorder the phase to coordinate the arterial road. Here we use the fuzzy logic that contain of the 3 input and 1 output. 3 input is named at remaining queue length, passing rate, and remaining time of green current and of current green phase. And the 1 output is denoted by extended, no change, and decrease. This is our proposed membership of 3 inputs. The first input have a 3 membership function, and the second have a 2 or have a 3 input membership function. This is the third input, and our output is no change. This means no decrease or increase. If we need to increase, we use the positive value or the negative value to decrease. This is a sample of a fuzzy rule that proposes it. If, for example, if the remaining queue length is short and the remaining time of the current green phase is short and the passing rate is 0, then the extent no change decrease is negative max. Negative max means there is a little cars and it is far from the stop line. For this, we need to decrease the current green time by the maximum negative number. This is our proposed arterial consists of 2 intersections, intersection A and intersection B. This characters represent the flow of the main direction of the arterial. F1 and F4 is the main flow of the main direction of the arterial. This value is illustrated in the negative in the next table. This value represented here. We produce a 3 hours flow. Each of the different flows that to represent the adaptive nature of the traffic signal. We use some restrictions to perform the simulation. Here we use the maximum vehicle speed is 50 km/h. Lost time is 3 seconds. The travel time between 2 intersections A and B is set to be 32. This is corresponding to the link between two intersections, that is 400 meters with 50 kilometers per hour. We compare our result with a non-optimized fixed time. For this reason, we use the mode 2 combination that set the value of the phase 1 and 2, phase 3, 4, 5, and 6 as 20 seconds, 45 seconds, and 15 seconds. For the back pressure, we use the back pressure, capacity-aware back pressure. For this reason, we use the capacity of the rod. For this reason, we use the default value of 5 meters of a vehicle and 2.5 meters of the headway gap between two vehicles. Using this, we calculate the capacity of each rod. We performed the 3-hour simulation. During this simulation, the number of 14,761 vehicles were passed during this interval. The obtained simulation result, we use the 4 performance measurement index for a fixed time, cyclic back pressure. We use isolated fuzzy logic base and coordinated fuzzy logic base. From the waiting time, we obtain the 77.06 for a fixed time, while for a coordinated, we obtain it 50.70 seconds with a standard deviation that is corresponding to each method. For every travel time, we obtain for a fixed time with its fuzzy, with its standard deviation. This is the obtained result for the travel speed along the arterial road. Here we represent the Q links or accumulated Q link at intersection A and at intersection B. For a coordinated fuzzy logic base. The maximum value here is less than the 120, and for the isolated fuzzy, the value is slightly more compared to our proposed coordinated method. Here, the total Q length of a cyclic back pressure, here is the value is near to 120, and for a fixed time is the worst one. As a conclusion, a decentralized adaptive signal control strategy based on fuzzy logic and modified Webster optimal cycle formula is proposed. To maintain coordination between successive intersections, the information such as traffic demand, coordination phase, remaining time, and Q length are exchanged between local and neighbor intersections. In this work, we attempt to coordinate between two intersections through the reordering of the phase sequence to adjust the offset. The performance enhancement, for example, in average waiting time is about 34% and 16% with compared to the fixed time and back pressure, respectively, our proposal. To accomplish good result, we recommended that the mathematical model to calculation the speed of the vehicle based on the existing density of the road must be used instead of the fixed travel time where I use it here. Thank you.
Thank you very much for your presentation. Unfortunately, I see some advantage of this online conference because organizer cannot kill me. That is too much delay. But I hope.
I trying to manage.
No, it's not your fault because it was my fault. I was responsible to keep time, no. So you don't take it on my. So unfortunately, I think that we cannot have too much time for questions. I just tell you that in Sweden we have everywhere the sensors that help to control the traffic as well. So I see Darius is already present on the screen. Do you want to see something, or because I propose that every participant open your let's say video, that we can see all beautiful faces and even those less beautiful. And we just salute organizer. I think, Darius, that it was great opportunity to have this presentation online. So I think that we should applaud Muzamil as well, but you as organizers as well. So please, everyone.
I think, yes, we can applaud to all of us,
yes,
to all
please.
participants.
And sorry for the problem that we couldn't be with you today.
Yeah, it's a pity, but we will see how it's going next time.
But we see anyway Okay, do you have
so thank
any...
you all presenters, Mr. Chairman as well, and hope to see you next times, maybe in Palanga.
Thank you very much. Take care. Bye.
Thank you.
Bye.
Bye-bye.